training in well quality assurance and quality control. Section 6, Non-Destructive Testing. Topic 3, Principles of Penetrant Testing. The objective of this topic is to identify the basic principles and applications of penetrant testing. Penetrant testing is a highly sensitive, non-destructive method used for detecting discontinuities which are open to the surface, but less likely to be detected by visual inspection alone. As an example, a flaw such as small porosity open to the surface could be overlooked during visual examinations. However, with proper application of the penetrant test, such flaws would be exposed. Like other non-destructive methods, penetrant testing has its own unique characteristics. It relies on capillary action, which is the tendency for a liquid to redistribute itself into and between closely fitted surfaces. This characteristic can allow a liquid or dye to penetrate and expose flaws or discontinuities in welded materials. Because the penetrant is a liquid, it has certain limitations. Generally, it is not recommended for materials with very porous surface conditions, or which are highly absorbent. Using the penetrant method here would likely give false flaw indications. The two basic types of this test are fluorescent penetrant and visible dye penetrant. Both types have several variations, although both share the same basic procedure. The application of a liquid penetrant, removal of excess penetrant, and the application of a developer to draw the penetrant from any openings in the surface. The main concept of both types is the reading of two contrasting colors. In the case of fluorescent penetrant, the contrast is created by a dye which turns a brilliant yellowish green on a deep violet background when exposed to an ultraviolet light source. Now, this is the more sensitive method. Visible dye penetrant is used under normal lighting and normally appears as a bright indication on a white background. This method is quite easy to apply and needs no special equipment. For either test, the cleanliness of the surface before the application of penetrant must not be overlooked. Matter such as scale, slag, grease, paint, rust, and so forth must be removed to allow the penetrant to enter surface openings. There are a number of cleaning methods, such as chemical solution baths, steam cleaning, or vapor degreasing. Precautions should be taken before performing cleaning operations because some solutions may be toxic if inhaled and may also be violently inflammable. Grinding, chipping, machining, or shot blasting should be avoided, since these processes could mask small discontinuities and prevent accurate inspection. When the surface has been properly cleaned and dried, the penetrant is applied by spraying, dipping, or brushing the test area. The most portable and convenient method of applying penetrant, cleaner, and developer is by the use of pressurized spray cans. The water-washable form of penetrant is basically a dye placed in a water-based solution. For non-porous materials, it provides the lowest degree of sensitivity due to the ease of penetrant washout of shallow openings during cleaning. Post-emulsifiable penetrant consists of dye placed in an oil-based solution. This variation requires the additional step of applying an emulsifier before the removal of excess penetrant, which chemically breaks down the excess and makes it water washable. Now, since the oil-based penetrant remains in the openings as the emulsified penetrant is rinsed away, this allows greater sensitivity for shallow surface discontinuities. Whatever form of penetrant is used, sufficient dwell time must be allowed, so that the penetrant can find and seep into any openings. The dwell time is based on the type of material and the degree of accuracy required. Longer times allow the flow of penetrant into more and smaller openings. Refer to the testing procedure or manufacturer's recommendations for specific times. Generally, the dwell time can range from 5 minutes up to several hours. When the dwell time has elapsed, the excess penetrant is removed by the appropriate method. For example, a solvent cleaner called a remover can be applied to a towel and the surface thoroughly wiped clean. After the surface has been properly cleaned and dried, the developer is then applied. The developer acts like a blotter, drawing out the penetrant left in openings of the test area. Whatever developer is used, it is important to apply a smooth, even coating over the surface. Heavy layers can obscure very small indications. After the developer has been applied, allow for correct dwell time before examination. Usually this is about half the penetrant dwell time, or whatever the test procedure recommends. Caution should be taken when performing this test on multipass welds. All penetrant must be thoroughly cleaned between every pass, since welding over test solutions could very well cause discontinuities to occur. Penetrant testing is an invaluable quality control technique. However, like visual testing, care must be taken in drawing conclusions. For example, the depth of a flaw cannot reasonably be measured. The inspector can only see penetrant indications that appear on the surface. In general, though, the larger the flaw and the longer the time allowed for penetrant bleed-out, the larger the indications will appear. But because the amount of bleed-out is based on the volume of the opening and not the depth, accurate depth measurements are not possible. In conclusion, remember that the proper application of this test is based on the steps discussed and by following the details of the written test procedure.